is the need of taking oxygen into the body. That is for aerobic respiration, to oxidize the food, to get maximum energy, oxygen is necessary. So that's why the living organisms will try to collect that atmospheric air into the body. That intake of oxygen may be through diffusion or with the help of some specialized organs. So through such organs, exchange of gases takes place. In our body, lungs, so we call our respiration as pulmonary respiration. In aquatic animals, branchial respiration, in which gills play a major role in exchange of gases. In insects, which are terrestrial insects will have trachea, tracheal system. And in some organisms like worms, skin will play main role in exchange of gases, cutaneous respiration. And in the total, right from intake of oxygen up to oxidation of food, releasing of energy, we can understand that complete process under 5 headings. First one is breathing. Second one is external respiration, in which exchange of gases takes place between respiratory organ and blood. Third is transportation of gases. And the fourth one is internal respiration, that is nothing but exchange of gases between the blood and cells. And finally, the last phase is cellular respiration, in which oxidation of food takes place inside the cytoplasm and of course inside the mitochondrium. You can understand later. So glycolysis takes place in cytoplasm, Krebs cycle electron transport takes place inside the mitochondria. You know, powerhouse of the cell, that is mitochondria. So like this, in 5 phases, we will understand that respiration completely. Before going to that process of respiration, first we must know what are the different organs present in our respiratory system. So in human beings, the respiratory system consists of some organs like nose. The first organ, the nose will help in taking off air, atmospheric air into the body. That leads into nasal cavities. These nasal cavities will open into pharynx. This pharynx, we have seen that in digestive system also, in alimentary canal. That is a common passage for both air and food. So this pharynx will lead into larynx in respiratory system. This is commonly called as voice box, in which we can see vocal cords. With the help of vocal cords, we make sound. We speak with the help of larynx. This larynx is the anterior part of trachea. So the next organ is trachea. This trachea is a tube present in thoracic cavity. Right from the head through the neck, the trachea will reach thoracic cavity. In thoracic cavity, where we can see fifth thoracic vertebra, in that region it will bifurcate into 2 branches called as bronchi. 2 bronchi are formed. From this bronchi, bronchioles, small branches of bronchi, and finally these will enter into alveoli. These are the units of lungs. So we have to understand about lungs. So these are the organs present in respiratory tract. In digestive system, we have seen alimentary canal. Digestive tract is a continuous passage in which the food flows. Like that, this is a continuous passage in which air will flow, air will move. From atmospheric air through these organs, in this series, the air will passes up to lungs. The air will reach lungs. Then only the lungs will help in exchange of gases. So from this lungs, oxygen will enter into blood. That is nothing but external respiration. So let us see about nose. So these are the organs present in respiratory system. Respiratory system. So now this nose, externally on the face, we can see nose. The nose is having one cartilage, that is hyaline cartilage. The nose tip will be very flexible because of cartilage. At the base of the nose, we can find bone. So bones are also present in the nose, that is concave. Concave. So of the nose. This nose, how it will help in intake of air? The nose has two openings. The two openings are called external nostrils or nares. External nares or nostrils. So the two openings are separated by one membrane. The two openings, in between the two openings, we can find one membrane. That membrane is called as septum, nasal septum. Nasal septum. The nasal septum is continuous, it is spreaded deeply. And now, this external nostrils or external nares will open into cavities. Inside the nose, deeply inside the nose, we can find chambers. The cavities are called as nasal chambers or nasal cavities. So, external nostrils. From here, through these external nostrils, the air will enter into nasal chambers. These nasal chambers, how many in number? Two. Because how the two openings are separated from each other with the help of nasal septum. Due to that extension of nasal septum, the internal chamber is also divided into two chambers, nasal chambers or nasal cavities. In digestive system, I said buccal cavity. Above buccal cavity, the roof of the buccal cavity is palate. Above the palate, we can find nasal cavities. So that means that same palate which came in digestive system is forming the floor for nasal cavities. The same palate is the roof for buccal cavity. So in between nasal cavity and buccal cavity, palate is present. So the palate divides or differentiate that nasal cavity from buccal cavity. But here the difference is buccal cavity is a single one, a big chamber, whereas the nasal cavities are two in number due to the presence of nasal septum. Okay. Now each nasal chamber is divisible into three regions. If you see in the mirror your nose through external nostrils, you can see some internal region also. So in the anterior part, in the beginning region, Inside the nose, we can find hair-like structures, cilia-like hair. So that region of nasal chamber is called as vestibule. We use this term in digestive system also. Mouth opens into buccal cavity through vestibule. There, what I said, the gap between the cheeks and teeth, that gap is called as vestibule. But here, the vestibule is the anterior part of nasal chamber. So, what you understood? Vestibule means the entrance region. The entry part of any region is called as vestibule. So, in this region, what we can find? Hair. You can understand this. What is the importance of hair? That will filter the dust particles or microorganisms. So it helps in filtration. Number one. Okay. So the vestibular part of nasal chamber or the vestibular zone of nasal chamber helps in filtration. This is very much important, necessary, no? If the air is not filtered, the dust particles will go and reach lungs. So it may cause infections. So that's why we have to prevent that entry of dust particles or microorganisms. Number one. Inside vestibule, if we cross that vestibule internally, the middle region of that is each nasal chamber is called as respiratory zone. Respiratory zone. So in this respiratory zone, what happens? You can see that is visible in the mirror. You can see that middle region of the nasal chamber also. That will be very reddish. Some mucous membrane will be there. That is reddish because that region is innervated by so many blood vessels. There, for example, if you are living in hot area like deserts, the air will be very dry. No humidity, no water content. If you inhale that type of dry air, the lungs will become dry. So it will lose moistness. So that's why we have to regulate the temperature of the inhaled air according to our internal body temperature. If we live in Himalayas, that air will be very moist. So that's why if we inhale as it is, the lungs will get infections easily. So we have to warm up that air if we are living in cool regions. Or if we are living in dry regions, we have to add some water vapor to that air before intake of air to the lungs. So that's why the temperature of that inhaled air will be regulated. It will regulate the temperature. So how it acts? The middle region that acts as air conditioner, because that air whichever we inhaled, that should be according to our internal body temperature. So the temperature of the air will be regulated, controlled. That is important function. And the DP, that is called as olfactory zone. You understood? That has the deeper region of the nasal cavity consists of sensory cells which can detect smell. So olfactory organ means organ helps in smelling. So nose is olfactory organ. So this helps in smelling. Now what you understood? See, nasal chambers are present inside the nose. Nasal cavities. This is nothing but that is a continuation. Now externally visible part is called as nose. Internally the chambers are called as nasal cavities. So they each one is having three regions. So what is the main function of nose? Means it will filter the air. It will regulate the body temperature of the air according to the body temperature. Third one is it helps in smelling. Okay. Now sometimes we take air through mouth. That is very common sometimes, unknowingly. At that time, there are some disadvantages. What are the disadvantages if we take the air through the mouth? the temperature of the air cannot be regulated, the air cannot be filtered, so that's why we get infections, right? So we have to inhale the air through nose only. We should not inhale the air through mouth. So why these things we cannot do with the help of buccal cavity? Okay, right. So now nasal chambers. Nasal chambers. In the previous diagram in the digestive system, I have shown like this. No, see, this is the palate. This is the nasal chamber. This is the oral chamber. So here, this is vestibule. This is respiratory zone. This is olfactory. Now, posteriorly, what is this opening? External nostrils. So through external nostrils, air will enter. This is the mouth. The food will enter. So here, posteriorly, there is another opening which opens into pharynx. Okay. So this opening is called as internal nostrils or internal nares. If you try to recall, I said at the time of swallowing food, the ula or soft palate will close that internal nostrils. It will prevent the upward movement of food. This is soft palate. So what is this opening? Internal nostrils. Internal nostrils. So this internal nostrils will connect the nasal chamber with pharynx. So the next organ is pharynx. These internal nostrils are present in between the nasal chamber and pharynx. Now through these internal nostrils, air will enter into pharynx. Again, no need to repeat. This pharynx is divided into three regions: nasopharynx, oropharynx, laryngopharynx. The points are common. It may be from digestive. So when we inhale, that inhaled air will reach vestibule, respiratory zone, later olfactory zone. Through internal nostrils, the air will reach nasopharynx, laryngopharynx, and later on, here two openings are present. I said one will lead to esophagus, another one will lead to trachea. Okay, so now the air from laryngopharynx, it must enter into trachea. Posteriorly, what is present? Esophagus. Food must enter. Here I explained epiglottis is present, right? So now related to pharynx, the points are same. You can write the same points in respiratory system also, whatever you studied in digestive system. So now come to larynx. What is this larynx? That is commonly called as voice box. So here, if we see the continuation of pharynx, if this is the pharynx region, if this is the pharynx region, this is having the previous organs regions are nasal chamber, oral chamber, buccal chamber. Now this is soft palate. This is pharynx. Now posteriorly there are two tubes which are continued from pharynx. This is pharynx region. The posterior part, this is anterior, that is ventral side, front part of the body. This is back part. So in the neck, this is esophagus. This is trachea. So here two openings are present. I named the two openings in digestive system. This is called as gullet. This is called as glottis. The openings. The opening of esophagus is called as gullet. The opening of trachea is called as glottis. Okay. The anterior part of trachea is modified into larynx. So that is nothing but trachea, tubular structure. The anterior part, some region, some area the beginning part of trachea is modified into larynx. Okay. So now it is dilated, a little bit dilated. If I draw the trachea like this, it is dilated like this, and we can find some organs inside that. Okay, like this. So this is trachea. It is dilated, it is expanded, and at the anterior tip, the trachea, it becomes larynx. So in this larynx, what are the points to remember? It is having 9 cartilages. 9 cartilages. Okay. Here I explained now. One lid is present, epiglottis, that is present here. That is present here, epiglottis. That is also one cartilage. In this 9, epiglottis is one. For competitive exams, you must understand, out of this 9, 3 are paired, 3 are unpaired. So which are the unpaired cartilages? Which are the paired cartilages? Paired, unpaired. Okay. So that you have to remember. Paired cartilage, arytenoid, cuneiform, corniculate. Arytenoid, cuneiform, corniculate. Each one 2 in number. That's why they are under paired. Okay. Totally how many? 6. Now under this unpaired, epiglottis, thyroid, cricoid. Epiglottis 1, thyroid 1, and cricoid 1. So totally how many cartilages are present in larynx? 9. Okay. So you have to remember these terms. Arytenoid, it is not unpaired, it is paired. Cuneiform, it is also paired. Corniculate, it is also paired. But epiglottis, unpaired. Only one epiglottis we can find, one lid on the surface of this opening. Thyroid, only one. Cricoid, only one. Okay. So you have to remember the names. Right? Then only you can answer that question. So out of the following 4, which is unpaired? That means they will give 3 paired and 1 unpaired. You have to recognize that. Identify. Right. Due to male sex hormones, in males, the thyroid becomes bigger. Due to male sex hormones, in males, the thyroid cartilage, which is present in the anterior part of trachea, larynx, becomes bigger. So that's why in the neck of males, we can find one bulged or protruded area. At the time of swallowing or taking water, it will move up and down. That is called as Adam's apple. So that Adam's apple is nothing but thyroid cartilage. It will be bigger in males than in females. Okay? Right. Now, along with these 9 cartilages, 2 vocal cords are present. Vocal cords. They act as the strings in the musical instrument. It may be guitar or violin. So in violin, in guitar, what is the importance of that strings? If we try to vibrate them, they will make sound. Okay, just like that, these 2 vocal cords, which are present in larynx, will vibrate when the air passes through the gap between the 2 vocal cords. Both the vocal cords will vibrate. At that time, sound can be generated. So now, the pitch of voice in males and females is different. If someone is speaking from far, without seeing them, we can say whether that person is male or female. That voice difference is due to difference in pitch. Okay, so low pitch will be from males, high pitch voice is from females. So that is due to male sex hormones again. Due to male sex hormones, the vocal cords become thicker. That's why they will vibrate slowly. So that's why the pitch of the voice will be slow, low pitch voice, right? High pitch voice is from females. That is due to very thin vocal cords in females, right? So that difference will be there. So there are 2 vocal cords in larynx, 9 cartilages in larynx, right? That's why with the help of these vocal cords, we are able to speak. We are able to make sound. So that's why larynx is called as voice box. Larynx is called as voice box. Any doubts? Right. Now, let us see trachea. Trachea. That is a continuation of larynx. That is tubular structure. Continuation. If this is trachea, if you want to draw the diagram, generally you will show lines like this in trachea, for this trachea. These lines are because of the presence of cartilaginous rings, which are in the shape of C-shaped cartilaginous rings. Why C-shaped cartilaginous rings? To protect or to keep the trachea always open. There must be some support, mechanical support to the trachea. So this C-shaped cartilaginous rings will prevent the trachea from collapsing. If it is very soft, if the trachea collapses, air cannot pass through the trachea. That's why all the time the trachea must be opened, the passage must be free to take the air in and out. So that's why C-shaped cartilaginous rings. Cartilaginous rings means they have that flexibility, but it will give mechanical support. Now, why we call it as C-shaped cartilaginous rings? There is some gap in each ring. That gap will be towards, I told you just now, if this is trachea, this is esophagus. Now, when we swallow the bolus from buccal cavity, in digestive system, what is bolus? It is the spherical shaped food which is formed after mastication with the help of tongue. So, we swallow the bolus. At that time, the spherical ball-like structures will start moving in esophagus. Okay, at that time, when the food is moving in that area, we can see a little expansion of esophagus. Because esophagus is muscular, it can show that expansions when the food flows. You can see, if you pump water through one motor into a pipe, that pipe will become thicker. And if you switch off the motor, immediately it will inflate. The pipe, which is rubber pipe, it will inflate. So that's why if the food is moving here, at that time, the wall of the esophagus may show some bulge. At that time, here, that effect or that pressure will fall on trachea. So at that time, we should not see any friction, because if there is any friction between the trachea and esophagus, that wall of both the tubes will rupture. So to prevent that wall of trachea and esophagus, that cartilaginous rings are incomplete, there will be some gap where the esophagus is present. So each cartilaginous ring is having that gap ventrally or dorsally. In our body, in the neck, trachea is present ventral side, esophagus is present posterior side in the neck. So that gap in each cartilaginous ring is present in which surface? Ventral surface or dorsal surface? Dorsal, because esophagus is present there. Here the gap will be there, right? So now when this trachea enters into thoracic cavity, in our body we can see some vertebrae in the neck. We call them as cervical vertebrae. 7 cervical vertebrae will be there. Vertebral column. In the thorax, we find 12 vertebrae in the vertebral column. Exactly in the area where 5th vertebra is present, thoracic vertebra, we call it as T5. Okay, thoracic 5. 12 thoracic vertebrae are present in that 5th thoracic vertebrae. So, in that area, this trachea will bifurcate. It will divide into 2 branches like this. These branches are also lined by cartilaginous rings like this. Okay? So, in which region the trachea is divided into 2 branches? In thoracic region. Exactly in the thoracic region where T5. Okay? Thoracic, 5th thoracic vertebra. In that region, it is bifurcated. Right. So now, how many branches are present to this trachea? 2. 2 branches. These branches are called as, each branch is called as bronchus. This is called as bronchus. This is trachea. Right? This is the first branching present in respiratory system. Before that, no branches. This is the first branching. So that's why we call it as primary bronchus. Only 2 primary bronchi will be there in each person. Okay, in every person we can find 2 bronchi. Which bronchi? Primary bronchi. Okay, singular is bronchus, plural is bronchi. Okay, that's why we can name them as left and right primary bronchus. Left primary bronchus, right primary bronchus. This is right, this is left. Okay, that will be opposite to you, who is sitting in front of the board. The directions will be different. For you, this is left, this is right. But for me, I am standing in front of you. So for me, it is opposite to your directions. So that's why right, left. Okay? Each primary bronchus, you have to remember, you have to listen carefully. Each primary bronchus is again divided into sub-branches when they enter into their respective side lung. So, primary bronchus will enter into lungs. So, we can find lungs here. Okay? So, the left primary bronchus will enter into left lung. The right primary bronchus will enter into right lung. Okay? So, the primary bronchi will enter into the lungs of their side. Okay, opposite side illa, crisscrossing illa. Okay, right. So now, like this, here also, we can find this type of lungs. Now, here, one thing I will tell you. See, the thing is, you know, in our body, heart is present in thoracic cavity only. Where the heart is present? Exactly in between the 2 lungs. In between the 2 lungs, there is some space. That space is called as mediastinum. That space is called as mediastinum. What is mediastinum? There is a space between the 2 lungs. In that mediastinum, we can see the presence of heart. You know very well, heart, if you want to check the heartbeat, sometimes we try to put our hand palm on the that left chest, because the ventricles are directed towards what? Left side. Heart is present at the center of thoracic cavity, but the apex of the heart, the pointed region of the heart, at the bottom of the heart, it is directed towards left. So that's why that pressure or that force will fall on left lung. Okay, so left lung we can find one notch. See, there is one bend that is absent in right lung. So this exactly the apex of the heart is located here. That's why you can see the shape differently for this left lung. Alright, this notch, this bend, curve present to the left lung is called as cardiac notch. Cardiac notch. Okay? Yake, why? Due to heart position of the heart. Now that's why if you see the length of the primary bronchus, listen. If you see the length of the primary bronchus, the right primary bronchus will be very short. The left primary bronchus is lengthy. Why? Due to the position of the heart, the lung is forced to, it is pushing that lung towards left side. So this a little, not so much, a little distantly that left lung is located. So both the lungs are not symmetrically present. Can you understand? So due to the position of the heart, the left lung is pushed towards the left side. That's why we can see that primary bronchus in the left side in more distant, means lengthy. Okay, when compared to right primary bronchus. Now you tell me, if the length of the primary bronchus is more, it has more chances to prevent the movement of microorganisms, because once if the microorganism enters into our respiratory tract, we have different types of reflex actions to push the dust particle away. We get sneezing when dust particle enters into our nose. So if the distance is more, it is having chances to trap the microorganisms. Okay, so that's why microorganisms will not reach this left lung easily, but right lung will receive the microorganisms very easily. So if somebody tells lung infection agide avarge, means which lung it should be? It should be right. Okay, so it is very difficult for the microorganisms to reach this lung. So this lung is more susceptible for infections. The left lung is having more immunity. That is due to the length of left primary bronchus. Okay, right. Now you tell me, which lung is suffering due to congestion? Left lung, because the heart is positioned in that manner. Due to the position of the heart, left lung is having that congested feeling, because that force or the pressure is not falling on right lung. So right lung is very free, okay, relaxed. But left lung is always thinking about that heart. Why it is disturbing me? That problem is not there for my friend, right? So that's why we can find what? See, we can find only 2 lobes in left lung, whereas here we can find 3 lobes. In right lung, 3 lobes are present, or the right lung is divided into 3 lobes. The left lung is divided into only 2 lobes. This is called anterior, this is called posterior. This is called anterior, posterior, medial. Okay? Right, or middle lobe. So what you understood now? Not only cardiac notch, in the presence of lobes also they are different from each other. Okay, which lung is having three lobes? Right. Which lung is having two lobes? Left. Okay, any confusion up to here? Right. Which will be narrowed? You tell me. Which lung will be narrowed? Left. Because that congestion is there, so it becomes narrow, thin. Whereas right lung is relaxed, so it will be broader. So this is narrow, this is broader. If you see the length of left lung will be more. It becomes narrow, slender, and more lengthy. Whereas it is very short but broader. Which one? Right lung is broad, short. Left lung is narrow, lengthy. Okay? And in number of lobes also, that is different. Right lung is divided into three lobes, left lung is divided into two lobes. Right now, what happens to this primary bronchus after entering into their respective lungs? They will divide into branches. The number of branches of primary bronchus is depending upon the lobes of that lung. You understood? So, left primary bronchus will divide it into two branches. Why? Only two lobes are there. So, this branch will come up to here, this will end here. In the same way, this will divide into, the left primary bronchus will divide into three branches. Like this. So, each branch will reach one lobe. Okay? So the branches of this primary bronchus called as secondary bronchi. They are not bronchioles. Okay? Secondary bronchi. That's why I will write that that is not enough. Still, the branching will be continuously present. Further branching is there. So that's why I will write the names of that branches. You have to remember that in the series. So what happened? Basically, let us start from trachea. Trachea is divided into primary bronchi. Primary bronchi. Each primary bronchus will divide into two or three secondary bronchi. Secondary bronchi. Up to here, number you have to remember. Okay, how many secondary bronchi are present in the left side? 2. Right side? 3. Later on, number is not important. Okay, that is not, we cannot count, that will be irregular in number. The next branching is called as tertiary bronchi. Till here, bronchi, we have to call them as bronchi because they have minimum diameter. Okay. Now each tertiary bronchus will divide into further branches which are smaller. They are called as primary bronchioles. Now bronchioles are coming. Primary bronchioles will divide into secondary bronchioles. Secondary bronchioles will divide into tertiary bronchioles. Tertiary bronchioles will divide into respiratory bronchioles. Respiratory bronchioles will divide into terminal bronchioles. Terminal bronchioles. Now, these terminal bronchioles will divide into alveolar ducts. Alveolar ducts. Each alveolar duct will enter into alveolar sac. Each alveolar sac has alveoli. Okay, that appears just like grapes bunch. Rib cage, we cannot see differences in the rib cage. The structure of the rib cage is same because it is skeletal structure. That lungs are in different shapes due to presence of heart. Okay, that will not differ from one person to another person. In every person, the left lung is divided to two lobes. In every person, in human being, the right lung is divided to three lobes. But rib cage, it is common. Okay, there is no difference in the shape of rib cage. Right. Once again, I will name. See, through trachea, the air will reach primary bronchi. From there, secondary bronchi, tertiary bronchi, primary bronchioles, secondary bronchioles, tertiary bronchioles, respiratory bronchioles, terminal bronchioles, alveolar ducts, alveolar sac, alveoli. When the air will passes in this channel, when we inhale, when we exhale, at that time the movement of air will be in reverse condition. At the time of expiration, the air will move from alveolus up to trachea to expel that CO2 out. In the process of inhalation, at that time this arrow marks will help. So you can show another arrow mark here. Okay. So this side it is inspiration, this is expiration. You understood? So you have to remember the series of that arrangement of branching. So it appears like what in botany, if you see one big huge tree, the main trunk which is present on the ground, that is the main trunk. This is similar to trachea. Later on what happened? This is the main trunk. It is divided into so many branches. Here, if you see the tree, the branching will be like this. Again, it will divide into so many branches. And you can see one canopy. But this branching of respiratory tract is in opposite direction to tree. So we can call that as respiratory tree. Respiratory tree is not present in garden. It is present in our body. You understood? So, this respiratory tree, what are the different branches in which the air will passes during inspiration? The question you have to read properly. That may be related to inspiration or expiration. In the options, if they skip one term, you should be very careful now. That's why primary, secondary, tertiary, that will be in series. But the confusion will come with respiratory bronchiole, terminal bronchiole, alveolar duct. Alveolar duct, it is very close to alveolus. We are using the term. But previous to that, respiratory and terminal. What is the meaning of terminal? Which ends, terminates. So that you have to remember. One important objective question here. Up to which branching C-shaped cartilaginous rings? What I said here, primary bronchus is also having C-shaped cartilaginous rings. Not only primary bronchus, illirutte, 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 illirutte. Istuvarige. Which is the first bronchiole? Primary bronchiole. These are all bronchi. This is the primary bronchiole. Up to primary bronchiole, the ducts are supported by C-shaped cartilaginous rings. Beyond that, beyond primary bronchiole, no C-shaped cartilaginous rings. They will be very soft because they are inside the lobules of lungs. Okay. Now in school, your biology teacher might have explained about layers, covering layers of lungs. What is the name of that covering layer of lung? Pleura. Pleura, the outermost covering layer. Okay. Covering layer of heart? Pericardium. Okay. Like that, all the internal organs are covered by protective membranes. So this pleura is a bilayered membrane. Two layers will be there in that membrane. What are the two layers? And in between the two layers, what is present? What type of liquid is present? That I will explain tomorrow. Thank you.
అదే